In today's lesson, we're going to talk about the atmosphere, which is part of the planet Earth. So let's start our lesson. In today's lesson, we are going to have different lesson objectives. We're starting first with the early volcanic atmosphere. We're going to study what was the early volcanic atmosphere. Then we're going to know the percentage of the gases found in the on the modern atmosphere. Then we're going to know how to separate the gases which are found in the air. And then we're going to talk about the pollution which is found in the atmosphere, and followed by how to find a clean alternative way or fuel in order to reduce the air pollution. The keywords for today's lessons are fractional distillation, acid rain, greenhouse gases, and global warming. So we're starting first with the early volcanic atmosphere. The early volcanic atmosphere was mainly methane or natural gas, CH4. The methane was changing by the help of oxygen burned in the presence of oxygen, the small amount of oxygen, to change into carbon dioxide, ammonia, and steam or water vapor. We're going to talk about the carbon dioxide first. Part of the carbon dioxide dissolved in the ocean to change later into sedimentary rock. The other part is was taken by the help of the plants in the photosynthesis process to change it into oxygen, and then the ammonia was reacted with oxygen, which is found in the early volcanic atmosphere, to change into nitrogen gas, and at the end the steam was cooled down to change into water. So this is how the oxygen, nitrogen, and the water came as a result of changing the early volcanic atmosphere through millions of years. Before we start talking about the atmosphere, first we need to know the percentage of the gases found in the air. In the air we have 78% of the overall gases found in the air as nitrogen. We have 21% of the gases in the air found as oxygen, 0.9% argon, carbon dioxide 0.04%, and other gases are representing 0.1%. So the majority of the air is found as nitrogen, followed by oxygen, and then argon along with the other gases. What are the importance of these gases? Let's talk about the nitrogen first. Liquid nitrogen can be used in order to preserve living tissues for surgical purposes. Nitrogen gas is an unreactive gas, or doesn't tend to react more frequently, so it's used in some of the industries, or mainly they can use it for filling the bag of chips, because it's going to prevent the food inside the bag of chips to react with the inner layer which is found inside the bag. Oxygen gas can be used in different industries. It can be used in order to produce steel from cast iron. It can be used in some of the torches in order to cut the steel or the metal. And oxygen is used in the cylinders in the hospital, so the people that have some problems in respiratory system can breathe easily. Argon is used to prevent the tungsten filament found inside the bulb from burning, so it stops the filament inside the bulb from burning. And the other noble gases are found in the lamps in order to give the lamp different lights, because these gases, when the electricity passes through it, is going to give out different colors. That's why it's used in the advertising. Let me ask you a question. Can we separate the different gases found in the air? So I want you to think about a way, if it's possible, how can we separate the gases found in the air? Simply the answer is yes, we can separate the gases found in the air. But before we separate the gases found in the air, I want you to remember two physical processes that we used to take previously. The first one is called condensation, the second one is called boiling. In condensation process, we tend to change a gas into liquid by the help of cooling. And in boiling process, we can change the liquid back into gas by the help of heating. and both of them takes place at a certain temperature. So let me discuss with you the process of fractional distillation that is used to separate the gases of the air in a quick way. We're going to take the air, huge amount of air, we're going to take it by the help of a suction machine in a certain container. Then we're going to cool down the air and we're going to apply pressure. At a certain temperature, which is about minus 200 degrees, with the help of the pressure, the air, which is gas, is going to cool down to change into liquid. This process is called liquefying the air. So it's liquefying process where we change the air from gas into liquid. Within this process, we have two gases that are going to change from gases into solids. The first one is water vapor. Water vapor is going to change at 0 degrees from gas to liquid to solid, so you can separate it easily. Followed by the carbon dioxide. Carbon dioxide changes into solid at minus 40, I think. So at that temperature, the carbon dioxide is going to change from gas back to solid, so you can separate it easily. Let's talk about separating the other ingredient. We have liquid air at minus 200 degrees. Then we're going to start warming it up. When we start warming the liquid air up at minus 196 degrees, the nitrogen is going to change from liquid to gas. So we can say that the nitrogen boils at minus 196. Then a person is going to ask you, Master, why shall we say nitrogen boils at a negative degrees? See, the process of changing liquid into a gas, this process is called boiling. So it doesn't matter which temperature the element or the compound will boil at, because every element has a certain temperature. As an example, water. Water boils at 100 degrees. It means below 100 degrees we're going to have the water as exactly liquid. Above 100 degrees we're going to have the water as gas. So we can say that 100 degrees is the boiling degree for the water. Water changed from liquid to gas at 100 degrees. Same as the nitrogen. Nitrogen is much weaker. It doesn't require a huge amount of energy in order to break the bonds between the molecule of nitrogen to change it from liquid into gas. So nitrogen, it doesn't require energy. At minus 196 degrees, nitrogen will be changing from liquid into gas. When all the nitrogen is given off as a gas, then we collect the nitrogen and we cool it down, we condense it, or we separate it by the help of condensation to be given off or to be collected outside as a nitrogen product by its own, pure nitrogen. Then at minus 186 degrees, when you warm up till minus 186 degrees, you know we're getting close to zero. So by increasing the temperature, we're getting close to zero. At minus 186 degrees, the argon is going to start from changing from liquid into gas. In another word, the argon is going to boil to change from liquid to gas. And then when all the argon is given off, we'll condense the argon to separate it into another container so we can have it as a pure argon. At minus 183 degrees, oxygen will start to boil or to change from liquid to gas, and by this process we can also condense it to separate it as pure oxygen gas outside. I hope you have understood the fractional distillation. Fractional distillation, again, it's a term that describes distillation process that takes place at different degrees. So we have started with cooling down the air to have it as a liquid, and then the air will be evaporated and then condensed. Evaporation and condensation, these two processes are called distillation. So fractional distillation, it's a distillation process which is made up of evaporation and condensation that has taken place at different temperatures, because we heat till minus 196 to get the nitrogen, minus 186 to get the argon, minus 183 to get the oxygen. So we have heated at different temperatures, so that's why we called it fractional, and distillation because it's made up of evaporation and condensation. Okay guys, so the boiling point of the gases found in the air as following: the carbon dioxide minus 32 degrees, the carbon dioxide changed from solid to gas in a process called sublimation. That's the only exception, and the proportion of the carbon dioxide in the air is 0.04%. Xenon minus 108, the xenon can change from liquid to gas. And you have all the other data. The important ones are oxygen minus 183, argon minus 186, and nitrogen minus 196. All of these are boiling at these temperatures to change from liquid back to gas. After we have discussed the proportions of the gases found in the air, we're going right now to talk about the air pollution. This picture is summarizing the overall problems that are found in the air. We have three major problems. The first one is called photochemical smog. The second one is called acidic rain or acid rain. The third one is called global warming. And you have the components that are causing each of these problems. So nitrogen oxides and unburned hydrocarbons along with carbon monoxide are making the photochemical smog. Acid rain is made by nitrogen oxides and sulfur oxides or dioxide. Global warming is made by the help of carbon dioxide along with methane, and at the end small contribution from the nitrogen oxides. We're starting first with acid rain. Acid rain is a major problem that is caused by the help of two important ingredients. You need to keep them in mind. I'm going to start first with sulfur dioxide, and we're going to talk about the nitrogen oxides after the sulfur. When you get a fossil fuel that is polluted by the sulfur, focus with me, I'm going to give you the story of the acid rain. Acid rain is made when you start burning a fossil fuel which is polluted by sulfur. This fossil fuel is going to have sulfur, so the sulfur is going to burn in the presence of oxygen to make sulfur dioxide, SO2. If we're talking about nitrogen oxides, then we're going to talk about the high temperature which is found in some furnaces or found in the engine of the cars. This high temperature is going to force the nitrogen of the air to react with the oxygen of the air to make nitrogen oxides. Can be monoxide, where one nitrogen is connected with one oxygen, or nitrogen dioxide, where one nitrogen is connected with two oxygens. So when we have the sulfur oxide, dioxide, and nitrogen oxides, these are found as gases in the air. What happens is when it rains, the rain is going to be mixed with the sulfur dioxide to change into sulfuric acid, which is a strong acid, but due to the rain is going to be found in the form of diluted acid. On the other hand, when nitrogen oxides are mixed with the water, is going to change into nitric acid. So we're going to have, along with the water, sulfuric acid and nitric acids. These acids are going to have a huge impact on the earth. It's going to damage a huge amount of plants. It's going to damage the buildings, and we're going to discuss the effect of the acid rain right now. The first effect of the acid rain is to damage the statues or the building that are made of the limestone. Limestone is a base or alkaline substance, is a base. This base can be neutralized by the acid. So when acid is reacting with base, they are going to produce salt and water. And unfortunately, when the limestone is reacted with the acid, they are going to change the limestone, which is a solid substance, into a soluble salt that is going to be washed by the rain. So basically, when you have a building which is made up of a limestone, you are going to, and we have acid rain. The acid rain is going to wash off the building slowly, and by the time I'm going to show you some pictures which is giving you a clue about the effect of the acid rain. The second effect is the lakes. When the acid rain come across a lake, is going to decrease the pH, is going to make the water more acidic. The acidic lake is not going to help the fish or the marine life to take place in the lake, and this is going to impact the plants along with the fish, so it's not going to have a pleasant effect on the lake. Last point, the nutrients which are found in the soil. The acidic rain or the acid rain is going to leach the nutrient from the soil, which is going to make the soil poor or acidic, so no planting, no farmers are going to be able to plant this particular soil. They need to neutralize it first. The remedy for the acid rain, you can add lime, as we have discussed. Do you remember the limestone cycle? We said lime can change into limestone can change into lime. So we can add lime that can neutralize the soil, which is going to make the pH of the water a little bit higher, if we're talking about the lake, or it's going to make the pH of the soil a little bit higher, so the farmers or the marines can live and can survive, or the plants can grow in that particular environment. The second way is to fit scraper. The scraper is going to prevent the gases from getting outside, and will not going to make the gases pollute the atmosphere, so we're not going to have this particular gas in the air, so we're going to have a safe environment. Scraper is used to be placed on top of the furnaces on some of the factories in order to reduce the gases given off by the factories. The second problem is the car exhaust. Car exhaust is one of the major problems that can cause huge pollution to the air. We have the source of the pollution: nitrogen dioxide, carbon monoxide, and lead. These three gases are making a huge effect on the air. So starting first with the photochemical smog. From the word photochemical smog, photo, it has an effect on the vision. Chemical is based on the chemicals found in the air, and smog, this is a huge phenomenon. I'm going to display the following picture for you to know what is the photochemical smog, which is caused by the nitrogen dioxide. The second problem is carbon monoxide. Carbon monoxide is a toxic gas that has no smell, no color. So basically you don't know how it smells, or you can't see it. So it can be mixed with the air easily, and this gas is very toxic, and huge amount of carbon monoxide or small amount even can attach with the red blood cell to prevent the red blood cell from carrying oxygen inside our body to the brain, so it can lead to death in many cases. Lead is a neurotoxic metal. It's very dangerous, and it's one of the main reasons why some children in some countries have learning disabilities. That's because the lead is damaging part of the brain. The catalytic converter. Catalytic converter is one of the remedies that can be found for the car exhaust. Catalytic converter is a device that can be placed inside the car in modern cars. This device changed the nitrogen oxides into nitrogen and oxygen. It changed the carbon monoxide and burned it completely to change into carbon dioxide. It gets the unburned hydrocarbon oxygen in order to change the unburned hydrocarbon into carbon dioxide and water. But catalytic converter cannot work in the presence of lead. Lead is going to poison the catalytic converter. That's why if a country is using lead in the presence of the petrol or with the petrol, is going to damage the effect of the catalytic converter, and the people over there, they are going to have huge problems when it comes to the acid rain, when it comes to the carbon monoxide percentage in the air, and the people are going to have neurotoxic problems, especially the children's. So catalytic converter is one of the good solutions for the car exhaust, but you need to make sure that the petrol has no lead inside it or mixed with it. I'm going to summarize this problem for you. When the sun ray is coming to the Earth is absorbing a small amount of the sun rays or the heat that comes from the sun, and then is going to reflect the majority of the heat back to the atmosphere. This process takes place normally in the absence of the greenhouse gases. But due to the pollution, the carbon dioxide along with the methane, both of them are going to act as a barrier. So when the sun absorbs small amount of the heat and try to reflect the majority back to the space, the greenhouse gases are going to act as a barrier to prevent the heat from escaping to the space, and this is going to increase the temperature of the Earth, and this has taken place for the several past years. And when I was in college, the doctors over there, they used to tell us more about the global warming, and they have estimated 2050 to be one of the years where all of the ice that is found in the North Pole and South Pole to melt. So when it melts, it's going to increase the water percentage of the seas and oceans, and this is going to make all the coastal cities submerged with the water. This has a very, very, very huge impact on our future and our existence on the Earth. So please think twice before you use any product that emit carbon dioxide like sprays. So it's a huge problem where people have started to come together to start looking for some solutions in order to reduce the percentage of carbon dioxide and methane on the Earth. Okay, as we have discussed the problems that can arise within the fossil fuels and burning fossil fuels where carbon dioxide is given off along with nitrogen oxides, scientists were discussing lots of ways in order to use a green energy. Green energy or clean energy is a way to give out an emission-free or to produce no toxic substance to the air, so we're going to have a longer time on the Earth and nothing will be collapsed as the fossil fuel experiments. So we have different alternatives where we can use. The first one is renewable energy resource. You can find a renewable energy resource as a good way to get, as an example, electricity. We have hydroelectric power, we have geothermal energy, we have wave power and tidal forages. We have the wind power, we have the biomass and biogas, we have the solar energy. All of these are good examples for renewable green sources where the energy will be given out by the help of a renewable way and will not going to produce any toxic substances. Another way in order to have a green energy is using hydrogen to give energy instead of using fossil fuels. This was taking place in London. Scientists over there have made a comparison between the amount of energy given by the hydrogen and the amount of energy that given by fossil fuels. And they have found that the maximum amount of energy that can be given by a fossil fuel is the amount of energy that can be given as a result of burning the natural gas or methane. Burning each gram of natural gas is going to produce 56 kilojoule. And they have found that burning 1 gram for hydrogen can produce 143. So it's more than triple the amount or almost triple the amount of energy that can be given by the help of burning the natural gas. So as it's a very good way to give a huge amount of energy, let's see the waste product or the result of burning hydrogen as a source of energy inside the cars. This can take place in a thing called hydrogen cell. The hydrogen cell is going to have two different sides. The first one is called negative electrode. The second one is called positive electrode. Hydrogen will be moving from one side. When hydrogen is burned in the presence of oxygen, it's going to produce water vapor. Water vapor is not going to pollute anything, so it's going to be a good way to operate our cars with hydrogen, because we have no pollutant are coming up as a result of using the hydrogen as a fuel. Hydrogen have lots of advantages, but also it have some disadvantages. Using hydrogen as a fuel can be a good way or renewable if you're using the hydrogen from the solar energy. It has lower flammability than the gasoline. It's virtual emission free, produce no pollutant. It's zero emission for carbon dioxide, has no carbon dioxide nor toxins coming out of the process. The disadvantages: it might be a non-renewable resource if you are generating using the nuclear energy or the fossil fuels. If you get the hydrogen by the help of fossil fuels, is not going to be a renewable energy resource, unlike using it by the help of solar energy, getting the hydrogen from the water and solar energy. The second problem of the hydrogen as a fuel, that the cars are going to need a larger tanks in order to accommodate the hydrogen, and yet we have few filling stations that can supply the cars with hydrogen. And the last 2 points, that we need to redesign the engines of the car to accommodate the hydrogen as a fuel. Last point, it's a very expensive process at the moment, because we don't have some alternatives for this process which can take place in the industry. In today's lesson, we have spoken about the pollution of air. We have spoken about the problems of the air from the acid rain, greenhouse effects or global warming, and then we have spoken about good alternative ways in order to get the fuels. I hope you have enjoyed today's lesson, and see you next time.